A simple technique to communicate over distance is to shout. When you shout, the air carries sound waves from your mouth to the ears of the people who hear you. An engineer would say that you are at the source of an analog signal that is transmitted a given distance over the air. This communication method has clear limitations. The strength of the signal diminishes over distance. After relatively a short distance of a few yards, the signal will become so weak that the sensors on the receiving side will not be able to detect it. The second limitation is interference. Communication between other people and other background noise interferes with the signal to the point that even if I can hear you, I do not understand you. During the 19th century, several innovators tried to overcome these limitations by working on devices that transmit voice. The main idea was to use a device that captures voice and converts it into electrical signals. The electrical signals were then transmitted and converted back into sound using a device at the receiving end. Alexander Graham Bell's successful experiments with electromagnetic devices and his ability to obtain a patent for an apparatus for transmitting vocal or other sounds telegraphically in 1876 led to the founding of the Bell Telephone Company. In 1877, the company set up the first private phone line between Boston and Somerville, Massachusetts. This was the beginning of the commercialization of the telephone. In addition to overcoming the problem of who do you talk to when you have the first and only telephone in the world, Bell needed to resolve the problem of what do you do if there are too many telephones, and how to connect them all. As the number of phone users began to grow and more phone lines began to connect more and more cities, Bell Company faced a networking challenge. The basic infrastructure of hard-wiring devices was not scalable. It was clear from the beginning that connecting every two phones with a dedicated line, also known as point-to-point, is not practical. The solution was a switch, a device that can change network connections as needed. The telephone switch, also known as the switchboard, enabled connections on demand and created a new profession, the switchboard operator. Operators used wires and plugs to create one long line that connected two devices. Call disconnect was another responsibility of the operator, which had to get on the line and verify if the call is over or not. No wonder switch operators were the first ones to know all the hot gossips and rumors. In essence, the operator established a direct and dedicated connection between two devices by connecting lines or circuits. The circuit was established for the duration of the call and was disconnected when the call ended. For a few years, the system worked just fine. Operators connected and disconnected subscribers as needed, provided information, delivered messages, and even provided wake-up calls. Soon, people demanded more connectivity. They wanted to talk to people on the other side of town, and the telephone companies started connecting switches to each other. This led to the foundation of the network backbone. Growth created new problems. First, which switches to connect and how many lines should connect them. Then there was an issue with the quality of the call. An electrical signal behaves like the voice in the air. It weakens over distance and is subject to electrical noise and interference. A third problem was that call setup was a labor-intensive process, to the point that it was recognized as the growth-limiting factor. There were not enough operators to provide service. It was time to invent the automated switch and the numbering system. From now on, every subscriber was identified by a unique number, and callers dialed numbers on a key dial rather than talking to a live operator. The company that realized the value of connectivity between remote location was Bell Telephone Company, which was renamed AT&T in the 1880s. During that period, AT&T also acquired Western Electric, which became the manufacturing arm for telephones and telephone switches. Small service providers who did not analog distance capabilities were forced to join AT&T, and in a short period, AT&T became a solid telecommunication monopoly that provided equipment, infrastructure, and service. In the 1920s, AT&T set up its R&D unit, Bell Labs, which focused on improving telephone technology. One of the research problems was how to improve the capacity of the network. Engineers had to predict utilization, number of calls at any given time, and blockage due to calls that cannot be completed. With this knowledge came service-level standards and the realization that a new technology is needed for the national telephone network. While the automated switch solved the service problem, the solution for both capacity and quality of sound came from a new field, computers. Computer technology enabled the conversion of an analog signal into a digital code. From now on, long-distance communication became a stream of zeros and ones. Transmission over digital rather than analog lines solved both capacity and quality problems. The poor quality of sound over analog lines was a big concern, and companies were bragging about the transition to a digital network and the improved quality of service. You may remember the TV ads with Murphy Brown in the 1980s when she could hear the pin drops over the Sprint network.
A pin drop.
For many years, the AT&T monopoly was considered a good monopoly since it ensured end-to-end compatibility and a nationwide universal service. AT&T installed the communication lines, built the switches, and even made the phones everybody used. In 1984, the AT&T monopoly ended, and the company split into 7 regional carriers and 1 long-distance company. The market opened to new long-distance carriers, and telephone companies could not set restrictions on who makes the telephone or owns it. Over the next 2 decades, regional companies merged, wireless service became popular, and the Internet was adopted as a transport infrastructure for many applications, including voice, data, and video.